Good morning. We'll see pointer arithmetic in C with examples. Pointer variables are also known as address data types because they are used to store the address of another variable. The address is a memory location which is assigned to the variable. It does not store any value. Therefore, there are only few operations which are allowed to perform on pointers in C language. So the operations which can be performed on the pointer are increment or decrementing of a pointer, addition of integer to a pointer, subtraction of integer to a pointer, subtraction of two pointers of the same type, and comparison of pointers of the same type. Now we'll see each of these operations in detail with some example. So first one is the increment or decrementing of a pointer. So here it is a condition which comes under the addition. Like increment is nothing but addition of 1 to the address. So when a pointer is incremented, it is actually increments by the number which is equal to the size of the data type for which it is a pointer. So suppose if the address of the pointer is 1000 and if it is incremented and if it is a pointer to an integer, suppose the integer takes 2 bytes, then if we increment the pointer which is pointing to this address, then it will be holding the address 1002. If it was a pointer of float type and the float data type takes 4 bytes, then the increment of the pointer will hold the address 1004. So let us see one example. Suppose in the main program, I have declared integer n which is initialized to 4. Now I am declaring two pointers. One is a pointer 1 and pointer 2 by integer star ptr1 star ptr2. Now if I assign the address of n to both of these pointers by ptr1 equal to address of n and ptr2 equals to address of n, and if I print the pointer 1 before increment is printf %p \n ptr1 and I increment the pointer ptr1. So now since the pointer 1 is pointing to the integer, then if I increment the pointer, then it will be incremented by the size of the integer data. So which I am going to print here, printf pointer ptr1 after increment which is ptr1. And also pointer 1 before decrement. So you will be seeing here the decrement also. Here it is ptr1 and if I decrement it comes back to the previous value of the ptr1. So this I can run it and check. So you can observe that pointer 1 before increment is some address which is whatever is shown here, and after the increment it is D8 because here it is taking 4 bytes for storing the integer, and before the decrement the pointer 1 value is whatever is at the end, it is D8, and if you decrement so it goes back to the original address which is D4. Similar to the increment, the decrement operation also will going to takes place. So if the address is 1000 and if you decrement by if decrement the pointer, then it will be decremented by the size of the data type for which it is a pointer, which we have already seen in the example program. Let us see the next operation, which is an addition. So when a pointer is added with a value, then first the value is multiplied by the size of the data type and then it is added to the pointer. So let us see one example program. As previous, so I have declared one integer variable n and initialized to 4, and I have declared two pointers ptr1 and ptr2 by integer star ptr1 and star ptr2, and I am assigning the address of n to both ptr1 and ptr2 by ptr1 equals to address of n and ptr2 equals to address of n. So I am printing the pointer 2 before addition message, and I am printing %p \n ptr2 by printf statement. And now if I add ptr2 by 2, then first this 2 will be multiplied by the size of the data type for which ptr2 is pointing, and here it is a integer data type. So the size of integer will be first multiplied by 2, and that will be added to ptr2, and then I am printing the value of ptr2. If the size of pointer is not pointer, so size of the integer is 4 bytes, then 4 into 2 plus 4 into 2 will be added to ptr1, which we will going to run and check it out here. So here you can observe the pointer 2 before addition, at the end it is 2 4. Then if it is 4 bytes, then the first increment will be 28 and the second increment will be making by 2c, which is 24 plus 12, 8, which is 2c. And the next operation is a subtraction, which is similar to your addition. So when a pointer is subtracted with a value, then first the value is multiplied by the size of the data type, and then it is subtracted from the pointer. So let us see one example. As usual, I have declared one integer variable n initialized to 4, and two pointer variables I have declared by integer star ptr1 star ptr2, and I have assigned the address of n to both pointer 1 and pointer 2 by ptr1 equals to address of n and ptr2 equals to address of n, and I am printing the value of pointer 2 by printf %p backslash n ptr2. Now if I subtract the pointer 2 minus 3, then first 3 will be multiplied by the size of the integer, because ptr2 is pointing to the integer, and that value will be subtracted from ptr2, which will be assigned to ptr2, which we can check it out by printing the value of ptr2 by using printf %p backslash n ptr2. So let us run and check the output. You can observe at the end it is 34. So once if you assume that the integer value takes 4 bytes, then the first decrement will be minus 1 will make address as 30, and one more subtraction will make 22c, and one more subtraction will make 28. So it is subtracting 12 from the 34 at the end, which is 34. So the next operation is the subtraction of two pointers. So the subtraction of two pointers is possible only when they have the same data type. Both the pointers are pointing to the same data type, and the result is generated by calculating the difference between the addresses of the two pointers and calculating how many bits of data it is according to the pointer data type. So it means that it will be finding the difference between the addresses and dividing by the size of the data type for which the pointer is pointing to. So let us see one example program. So as usual, I have declared one integer variable n initialized to 4 and two pointer variables integer star ptr1 and star ptr2, and I am assigning ptr1 equals to address of n and ptr2 equals to address of n. So now I increment the pointer 2 by 3. So when I do the increment by 3, ptr equals to ptr2 plus 3, first 3 will be multiplied by the size of the data type of the ptr2, which is here in this case integer. So 3 into 4 will be done, and then that will be added with the ptr2, and that will be assigned to the ptr2. Now if I take the subtraction of ptr2 and ptr3, so I am going to get 3, which is the number of data between the two addresses ptr2 and ptr1. So how it does is, here ptr2 value will be subtracted from ptr1 value will be subtracted from ptr2, and it is divided by the size of the integer data type. So here the difference was 12, which is divided by the size of the integer, which is 4, which will be getting the value of x equal to 3. So if I print, then I am going to get the value as 3. So we'll run it and check the output. You can observe the subtraction of ptr1 and ptr2 here is 3. Now let us see the pointer arithmetic on arrays. So pointers contain the addresses Adding two addresses makes no sense because there is no idea what it would point to. And subtracting two addresses will let you know to compute the offset between the two addresses. An array name which acts like a pointer constant can be used for increment and decrementing. So the value of this pointer constant is the address of the first element. So we'll see one example program. So let us declare one integer variable n is equal to 5 and an array integer arr which is initialized to 10, 20, 30, 40 and 50. Now declare one pointer variable int star ptr and assign the address of array to ptr by ptr equals to arr. Now if I want to print the values of the array, I can use for I equals to 0, I less than n, I plus plus, printf percentage d ptr of 0. And to go to the next element, I have to increment the ptr by ptr plus plus. So if I run it and check, I can observe that the values of the arrays will be printed. So 10, 20, 30, 40, 50 will be printed. I can also print the array elements by using star ptr. We'll check it out. So it works perfect. Now let us show the same function on the 2D array. So I have a function void traverse arr integer star arr. It's a pointer integer n and integer m. So inside the function I have declared the local variables int I comma j, and for traversing the 2D array I have two for loops for I equal to 0, I less than n, I plus plus, and inner loop for j equal to 0, j less than m, j plus plus. And to print the element I am first computing arr plus I into star I into m, which is going to go to the corresponding row, and for which I am adding the column address plus j, to which I am dereferencing. So which prints the ith row and jth column element. So here m is the number of elements in every row. So it has to be first multiplied, I has to be multiplied by m, to which the base address of arr will be added, to which the j, which is the column of the ith row, will be added, and it is dereferenced. And after printing one row, I have to go to the new line, which is done by printf backslash n. So in the main program, I have declared integer n equals to 3 and m equals to 2. So it is a 3 by 2 array. So int arr square bracket and second square bracket has the size 2, which indicates the columns are 2. So which is initialized by 1, 2, 3, 4 and 5, 6. So once I call the traverse array function by passing int star arr n and m, you can observe the result, which will be printing the matrix with the values 1, 2, 3, 4 and 5, 6.